I would not be that surprised to see the Riemann hypothesis solved by AI in the next 5 years. So far, it looks like diffusion of AI is going extraordinarily fast. The roadblocks that people expect to exist don't seem to exist in practice so far.
Now we have this concrete thing on record that economists are gonna point to and say like, these people are insane. They say we can get to 10% growth a year by 2035. And then like the AI people, they're gonna look at us and they're gonna be like, oh, these people are insane. That they only projecting 10% growth by 2035.
I would like to note, by 2040, we are at the point where my forecasting fails, it goes bananas. The next stage after this might look very intense.
Hello everyone, welcome to Epoch After Hours. I'm Jaime Sevilla, I'm director of Epoch AI, and I am today joined by Yafah Edelman, our new head of data and analysis at our organization. How are you doing today, Yafah?
I'm very excited to look at this and discuss how the trends, which we've been, monitoring for years, have implications for the future and where we think things are going. We've done a lot of studying the past and, analyzing what's going on. And I think we've developed a lot of thoughts on where things are going. And I'm excited to work them out with you.
A lot of how I will describe this exercise here that we're doing is projecting these lines that we've been collecting into the future, doing the straight line approach to forecasting on AI to a greater degree of the speculation that we have dared do before, and seeing where those lines are going to take us. All right, let's talk about like how much can we keep up with the current regime. So right now, this rate of scaling, it's very, very fast. Like we're talking about the scaling like 5 times a year. How long can you keep this up?
So, I expect to see a slowing down from 5x in the next, I would say 2 years. I think that we're probably not at 5x anymore. Basically already is a little bit slower, I think, just because the data centers of today are taking a long time.
Wait, that's a pretty bold claim here. Like even taking into account like the stated plans for Stargate and Abilene, do you still think that we're not going to be able to keep up 5x per year in the next 2 years?
Yeah, I think so. It's possible. So there's a question here about what's driving it. If they wanted to keep up, like if they were willing to use all of Stargate once it was built to do a very long training run, they could. They can totally keep up. The capability is there. My expectation, though, is that we've already seen some of the longer training runs in terms of duration, a few months, and that's a big part of what's driving the scaling of training compute. And I think just R&D time and everything has become a big enough deal that you won't see that increase. And once you remove that from the equation, then you're at 3x. Or 2.5 or so in terms of just how much compute you have.
Can we go over the numbers here and like make sure that that I understand? So things that I will push against. One of them is like actually I do think that there is like a very explicit intention here of like we're building these giant clusters to train a biggest model. Like the Memphis cluster that was built by XAI, like it has been pretty much in its entirety used for training Grok. That is my model belief.
I think we know that the Grok 3 in particular we know it was trained on about 80,000 GPUs, we think. And the cluster at the time had somewhere between 100,000 and 200,000 GPUs. And the cluster did have a decent amount more, and definitely very soon had a lot more, not too long afterward.
When did Grok 3 came out again?
Earlier this year.
Okay, yeah.
Grok 3 came out earlier this year. Grok 4 also came out. It's possible Grok 4 was trained on more GPUs. Important to note, though, we definitely don't think Grok 4 was trained. We think that the amount of additional compute that was done for Grok 4 is less than that was done for Grok 3 in the first place. Grok 4 was a Grok 3 plus some RL on top, additional reinforcement learning, and we don't think that, so like it seems very possible if they trained it on more GPUs, it would have been for much shorter. And if they trained it on, it seems also possible that they trained it on fewer GPUs for longer, or for a similar amount of time.
I see. Okay. Yeah, I think that it moves me a bit in your direction of like, okay, we might already be slowing down. On the training duration part, like, do you want to expand on why we expect things to not get any longer?
Yeah. So there's 2 reasons here. One of them is that algorithmic progress and compute improve over time. So the later you wait to start your training run, the faster your training run will go, the faster you'll be able to make progress. So there's that provides an incentive to use your compute for other things earlier on and wait for a little bit to train. This is part of it. Another part that I also think is very important in this is just the R&D time on applications and on algorithmic and on just like post training and on getting out products is very fast. And you want to get things out very fast. And I think that this is just a big enough deal that you don't want to have to wait 6 months before you even start fine-tuning your model, getting it ready for product, figuring out how it works. Just the point of getting it to the point where it's very useful for consumers. There's a lot of work even after the pre-training phase. So yeah, I think that 3 months, 6 months seems reasonable in terms of time. You could, of course, continue training them for longer, but there are decreasing returns to that.
Right, and this is so this will be one of the reasons why we might expect like the 5x per year go a little bit down, but not that much, right? Like right now, training durations in the last 5 years or so for frontier runs, they have grown around 30% per year, if I remember correctly.
I think we got a bit higher than that.
Okay.
I think right now we have something like if you take out training durations, we end up with something. We end up with somewhere between 2.5 and 3 increase in training compute each year, which is still pretty substantial. And there is room to go faster if they want to meet these deadlines, and if they want to scale continue scaling models at the same pace, they could switch from using parts of clusters, which I think is relatively common right now, to using the entirety of clusters. Like Grok 4 and Grok 3 could have been trained on a lot more GPUs. They could have done a lot more compute. They definitely, we know that I'm talking about these two because we know more about XAI's right now, at least. We know a bit more about XAI's compute than a lot of what's going on for the other companies, although we have some ideas of what's going on with OpenAI now, thanks to Stargate, and some research we've done into that. But they could have pushed and tried to keep up at 5x, and for at least a couple of years that is feasible.
But then it slows down.
It slows down. I also don't think they're going to push it. I think that we're probably going to be seeing a slowdown. Now this is complicated by the fact that we haven't actually seen. Probably you should add another year or so onto my estimate, just because the time between a training run starting and actually a product coming out can be quite long. We haven't seen, for instance, we believe that OpenAI has clusters that are far larger right now than the ones that we believe they've trained with. But probably later this year or so they'll have larger models coming out. Yeah.
Let's put numbers onto this. It is the end of the decade. What is the largest training run we have done? Do you get to 10 to the 29?
Do we get to 10 to 29? I think so. Yeah.
So for context here, 10 to the 29 flop will be a training run which uses 1,000 times more compute than current training runs. It will be the gap between GPT-2 to GPT-4. It was 10,000 times more compute, roughly. Yep. For as a sense of a scale. What do you get with that? What kind of AI do you get with that?
What kind of AI do you get with that?
Yeah.
This is a big question. I think I expect you to get fairly competent agents is one major thing you'll get. Agents that were the simple tasks, computer use tasks, are very consistently doable, very cheaply, and very fast. I expect simple failures of reasoning and confusion there's a lot less of them. And this alone is going to be a huge deal. You also probably see some other AIs. We see some ability to do reasoning that is sufficient to probably start making some novel discoveries in math, physics, other fields, probably especially in fields that get less attention from humans, or that have a few expert humans looking at them, as opposed to a lot, just because of the amount of competition that exists. By the end of the decade, I would not be surprised if you just don't have coders if people are just not writing code?
No, I will be very surprised if you don't have. Well,
People might still be telling the AI what to do,
okay,
designing algorithms, designing overall systems, but in terms of like writing
punching
code,
the
I mean, if you
lines.
want to write code that's easier, sure, go ahead. But like, it's already sort of at the point where I barely write code, and I do a lot of data analysis stuff, and I'll just have ChatGPT write all my code. I expect this to like extend to larger tasks being a problem.
Okay, fair. There's like this very big gap between automating the code writing and like automating everything that an engineer does in the day-to-day job.
Yeah. I'm not going to say that all of the engineers are going to be out of the job by the end of the decade, but getting to the point where AI can write all the code totally seems doable. Getting to the point where it can, it can prevent the code it writes won't have bugs, or it will be able to find and diagnose the bugs itself, will probably be doable. A lot of these. And agents that are able to do, I think, much more complicated extended tasks. By the end of the decade, certainly seems very feasible.
Yep.
Yeah.
Yeah, what else? I do expect them to be like really good at solving and advancing in scientific problems in math, physics, other STEM fields where there is like objective truth, so to speak. Like it seems pretty plausible to me that you are gonna be able to tell them like, okay, I wanna find a matrix with these characteristics, and it will just like go on its own, think for a couple of days, and then get back to you with having cracked like this hard problem that a human mathematician will take potentially weeks to solve. Yeah, to make a bold prediction here, like I think my model story, like by the end of the decade, like there has been one famous problem in like either math or physics where an AI has basically solved it. It has required like the input of like some smart mathematicians and humans to orient it in the right direction, but then like the actual bulk of the work was done by an AI.
Yeah, no, this definitely seems likely.
Which is crazy, right?
Yeah.
There's like Riemann Hypothesis solved by AI. Maybe not that specific one, but there's still like something.
I would not be that surprised to see the Riemann Hypothesis solved by AI in the next 5 years.
Yeah.
That definitely seems like very feasible. I mean, maybe it doesn't. I'm not a mathematician. But, AI, math, and a lot of these, checkable, rigorous fields that we currently think of as involving, one person thinking very hard, maybe not interacting with the world a huge amount. Those sorts of things, it turns out AI is particularly good at. And seeing them make huge strides in math definitely seems super possible.
Give me some color. Like where is gonna be the impactful applications of AI?
Where is going to be the impactful applications of AI? Yeah, this is a good question.
Like you automate call centers. This is one that comes to mind.
Yeah, I mean that's an easy one.
Yeah.
That's happening today. I think you will probably see a lot more. Seems plausible you see a lot higher quality technical products, programming, just things that would ordinarily require more dev time might just be a lot easier with AI or automatic. Let's see. What do you have ones in mind here?
I mean, I have takes. Like in particular with this part on having how AI coders affect the world. Like it does seem likely that it helps you like code up like quick things where like, I don't know, you're organizing an event for the weekend and you're just like, oh, just let the AI plan for you like a fancy app for inviting people, which is, again, that seems like very easy. That's things that already happen today. I do still think that the bulk of like commercial software is going to be developed under the management of like experienced software engineers who are like checking that things are like mostly correct, that there aren't like big bugs, like people care a lot about security in this context and such. Like you don't want to have like this unmaintainable slop of AI code that only the AI understands. That seems to me something that people are gonna be quite averse to.
Oh, I think I disagree with you on this.
Oh, really?
Or like, I think that the quality is going to be higher than human quality on like on the actual code.
I think it's gonna be higher, but people are gonna be nervous about not understanding it.
I just think that they're not going to vote. They're not going to be nervous with their wallets. I just think people, it's not going to be obvious which companies out there are, really doing different practices. And if in fact the companies which are using AI are getting are if in fact the companies that are using AI are just offering very similar products that are actually similar, or even better, and they're charging a lot less, it just seems really likely that people will just use those products. It doesn't, yeah.
Like, do I believe this? I do expect that. Definitely, I do expect that. Like, I could see that most code is being written by AI. I do still expect most code to be reviewed by software engineers.
I think that this probably depends to me. I think this might depend on the extent to which how wages for software engineers react to this.
Mm-hmm.
They might go down a bunch, which makes this more feasible. And also just on how much appetite there is for new software. If there's a lot of appetite for new software, then that puts a powerful incentive on not hiring software engineers.
Mm-hmm.
Yeah, I'm just not, I also just like, it seems like we're already getting near the point where AI isn't actually able to, where software engineers just aren't good enough to help by reviewing code.
Yeah.
Yeah, and I think that it's going to be an obvious pointless exercise for a lot of people. They'll have a few instances where they're like, I found a mistake, and they'll look into it further, and they'll be like, no, this was not a mistake. The AI was right. This will happen a bunch of times. It'll be really it sounds, I don't know. Maybe it will be so easy that they'll do it anyways, but it sounds really dispiriting to spend a bunch of time reviewing code that's much better than yours and won't have any bugs. And, if you assign someone to do this, they'll just be like, yeah, oh, it's good. I looked at it. Sure, right. Because they know it was. It's like, I think if it can write good code on the first try and replace coders, I expect this to happen very quickly. In general, diffusion seems to me like it's going to be extremely fast. It's just, everyone already has ChatGPT on their phones. It'll just be front and center on product. It'll be very easy to use. A lot of the things that currently make it harder to use will get solved. And it will be very obvious to a lot of people very soon after it's released. Any given feature is released. Very soon, I say maybe a year or two. Although I think possibly we measure. Yeah, I actually think this will be measured in months. That you will see if an AI is able to do things, it will just be doing them.
Yeah,
especially on the large scale of doing all of the coding, and even doing all of the coding without reviewing. The roadblocks that people expect to exist don't seem to exist in practice so far. Yeah. So far, we did a great piece on this. So far, it looks like diffusion of AI is going extraordinarily fast. ChatGPT was released 2023, late 2022, sorry, very late 2022. And it's now used by some large percent of the US population. They make quite a lot of money doing this, just from subscriptions. And it's only going to grow from there. And the adoption of additional AI features often won't involve like some separate app starting up. It'll just involve a feature getting added to ChatGPT, and they'll put advertisements, and suddenly everyone will be aware of this, just like the next day.
And AI can also help you adopt it faster.
Absolutely.
If you don't have the right scaffold to just plug it into your work, maybe you just ask the AI to build that scaffold for you.
Yeah, it'll help you adapt it to your work.
Yeah.
It also might, if a lot of people aren't adopting a feature that they could adopt because it came out and the last time they tried it didn't work, which I think is a real problem right now, it's not actually difficult for OpenAI to be like, hey, ChatGPT, just for everybody's accounts, review what they've been doing. If they've been doing anything which you have this new capability of doing, let them know that you have this new capability and give them a link. It's just, the diffusion seems to be, the problems of diffusion and integration all seem to be very quickly addressable. Much harder, the harder problems in terms of scale, in terms of things, and the slowdowns that I think are very likely, mostly come on the infrastructure and training side in particular.
So let's talk more about okay, we have this AI. I think that this AI is gonna be really good at many entry-level jobs. I think it's gonna be an AI that you can use to automate call centers, absolutely, that you can use to draft first contracts, absolutely, write a lot of code. I do still think that people are gonna have some hang-ups over oh, I still wanna have a human review what is being outputted by the AI. And this is, it's not so much a diffusion thing. And I think there's gonna be
I think they'll pay the human, and the human will have the AI do it and say it was good. And you can't tell the difference.
That's
You
fair.
won't be able to tell the difference. It's just like, even if, maybe you'll still pay a human, but the human won't need to do anything, and they won't, in practice, do a lot of work if they don't have to. Yeah.
Well, but then it's this kind of
Well-
weird equilibrium in which like you're hiring these people to just like use the AI when like you could just like have used the AI directly.
Yeah, I expect people to realize this is going on also, and to just use the AI directly. Or someone will launch a service which looks very similar to the other service, charges much less, and you'll find that, and you won't be able to tell the difference between the two services. The one that charges much less might be advertising a lot more, and yeah. Or there are additional options to make this happen. There are some companies out there which will buy up existing companies that are in this state where AI could do all of the work, and people are using AI to do all the work, but they're still paying people salaries, and they'll fire all the people, or reduce the number of people, or the quality of the people they're hiring because they don't think it's necessary.
But they still hire people. What are they hiring these engineers for in your world?
What are they hiring engineers for? I think there's a lot of things that aren't coding that are going on, just like figuring out what products do, figuring out how to architect things in a way that's easy to maintain to some extent, figuring out how to test things, just figuring out, what sort of products make sense, what sort of systems make sense, even on sometimes not like a final consumer product level, but what sort of things should we expose in our internal database or something. This will just seems like pretty plausible. You still have human engineers who are doing this, who are thinking about what sort of things are feasible, deciding on things to test, having the AIs test it. All of these things seem plausible. When I talk to engineers, people who are programmers, a lot of them I know don't spend their time programming.
Yeah.
Especially the more senior ones. They spend their time testing things, talking to other teams, editing config files is one thing I've heard. Just things that are figuring out how to tell the technology what to do more than building the technology.
Okay, so end of the decade, we have this AI. It has been trained on a lot of compute. We're using it, and it can automate all coding. It can automate many of these tasks, which are kind of low context that an entry-level person could do. And then most people, what they're doing and what their job is, at least in context, are kind of at least in office contexts, are managing AI to produce the thing.
Yeah. This seems plausible to me. I think they'll have a lot. I don't think they're going to spend their time managing AI. I think they'll spend their time talking to other people, doing other things. The managing the AI bit will, not take up too much of their time a lot of the time. Something I've noticed in AI use even now is that if I have to spend a lot of time talking to the AI, then it probably means it can't quite do the thing I want it to do.
Yeah, we're the management, to be clear, I think it also involves a part of I tell you something, and then the AI just gives me a mock-up for the website, and I look over it, and I'm I want you to change blah, blah, blah.
That sort of thing, definitely, okay, I think I've changed my mind. In fact, managing AI does seem some sort of variant of this, where you're interacting, seems very possible. Okay. Do you think we'll be seeing, what sort of economic impacts do you think we'll be seeing in terms of revenue and GDP growth in 2030 or beyond?
So here's the thing, revenues right now are in the order of tens of billions of dollars for AI companies. They have been growing very fast, on the order of 3x a year. Tripling your revenues every year is incredibly hard to maintain, but it's not crazy to me that you can double your revenues every year from here until 2030. And that already gets you really big. If you have AI companies producing multiple hundreds of billions a year, that already will lead you to doubling the rates of growth, of economic growth that we see right now, which in modern economies, they fluctuate around 2% a year. They have been stable like that over the last 70 years.
Right now, we see NVIDIA making $100 billion a year already. And we're likely going to see much more than that. Not to mention the efforts to build the data centers to host these chips, or the investments by TSMC to build fabs to produce chips. And all of this is at the cutting edge of AI in a way where the consumer products might not be. We've already found this stuff is useful. What's going to be the next step? And this stuff is you have to start building for the next step and the next stage. And so you might see trillions at this point. Definitely seems plausible you'll see trillions in yearly spending on things like compute, on things like GPUs, on things like fab investment, on infrastructure, data centers, and projects that look already they're very, very large, and they could just keep getting larger. And this might show up even in like the economy even more than actual applications of AI by 2030, just because it's a little bit there's some lag in terms of when you've built the data center. There's a decent amount of lag from when you invest to when you actually get the results, and the investment the investment runs a little bit ahead of the current day.
Okay, so end of the decade, we have AI that's producing hundreds of billions of dollars of value a year. I do argue that is enough to already see growth rates accelerate, and maybe see them go from like 2% a year growth rates to like 4% a year growth rates, which in my book is already quite massive.
I think it's like plausible. Do GPU spending show up in GDP? I'm not actually sure. I think it's plausible they're just like secondary effects from the amount of infrastructure spending at this point are even more obvious in terms of like just the economics. Just like hundreds of billions of dollars in this and trillions of dollars, substantial fractions of the US's GDP being invested in infrastructure. Assuming scaling is still continuing, which seems very likely. You'll see people building these fabs, building more fabs probably. The scale of like planning and data center size will increase dramatically. You'll see some slowdowns, or you'll be at a point, just like the infrastructure spending seems likely to also have effects on just like what's showing up in the economy. The way I think about it is this. Investors have a very reasonable uncertainty about what order of magnitude of money should be spent on AI. Should it be billions, trillions, hundreds of billions, tens of trillions? It's very unclear. And they're uncertain about this. They don't want to overshoot by several orders of magnitude. If you do, you've lost very, very large amounts of money at this point. And they've had to deal. There's been other technology in the past which scaled up and which they had similar uncertainty about. In the internet with the dot-com bubble, and railways in the past in the UK, where there's this very quick scale up and lots of investment. One way to handle this in a way that doesn't have you massively, massively overspend and doesn't risk that is take whatever exists in the current day in terms of results and project that things will continue at the current speed for another year or two. And this of exponential growth. So you'll predict that NVIDIA might make 3x more or 10x, between 3x and 10x more revenue than it is right now, and you'll invest based off that. And if you're investing based off that right now, you don't need a huge amount more fabs. On the other hand, this stops being the case if you are at the point where NVIDIA is making trillions of dollars and hundreds of billions of dollars in revenue to companies like OpenAI. Then you're going to have to build more fabs, even if you forecast out only a few years, a few generations of the technology. There's a complication here where at that point the number of years will increase because the time between when you can invest and get this next generation is longer because you have to do more complicated and large infrastructure projects.
I think this gets at the core of why our economic modeling has been so aggressive. I think these kind of effects are hard to build into an economic model that actually is built on the premise that scaling is going to continue.
What kind of effects are hard to build onto this?
Like these effects where like people are reluctant to invest and like take a huge bet from the beginning because they are like nervous about like, maybe this thing is going to completely collapse.
I think this is our prior work gate. This is my main disagreement with it, or I think this is my single biggest disagreement with this. Its investment model assumes people are willing to invest in this way where they're evaluating probabilities and uncertainties. And I think if I'm talking about modeling the future, just empirically, I think what we've seen is better matched by assuming scaling continues, they will be willing to spend some fraction of the current revenue of AI, some multiplier of the current revenue. Yeah. They'll be able to invest. Yeah, so if AI is making 100 billion, they'll be willing to invest 1 trillion or something of the sort. Or 10 billion, they'll be willing to invest 100 billion.
Yep.
Something of this sort. with some details. Sometimes it's not revenue. It's more about sometimes to some extent results can be compelling. Although I think as we move into the stage where it's becoming I don't want to say a more mature technology, but a technology that's having financial impact.
So let me introduce you to Yafah math on investing. Yafah math on investing is telling us like the amount of investment that's going to flow into a field in a year is like 10x the amount of revenue that field is generating. And every 10x scale in infrastructure build out in AI is going to take 1 year later. Is that a good summary?
Yeah, it's going to take every time you want to scale. If you want to scale to the next 10x, it will take an extra year. So the first time it will take 1 year. Second time it'll take 2 years when you want, and so on and so forth. These numbers very approximate, but yeah, this is my model of how things work.
Yafah math, folks. You heard first here. Okay, so let's center back to our story so far. For the next 5 years, we expect that scaling continues. People are investing more, revenues grow alongside that because you get to automate more and more tasks. And this gets you, by the end of the decade, to people having launched like 10 training runs are like 1,000 times larger than what we have now. It leads you to revenues that are in the multiple hundreds of billions of dollars, which like already have a measurable effect on economic growth rates.
Yeah, this seems. Yeah, I think I'm on board for this.
Yeah. So
yeah.
I think that for me here is where like the story a bit bifurcates, and I hesitate a bit on like saying which way it goes. Like there's a world in which things like just radically slow down and it just takes a very long time to keep growing. So there's another one in which like you just keep automating more and more, and that accelerates growth rates, and those accelerated production you can put back into AI.
Yeah, so I think there's like 2 stages here. There's the infrastructure scaling up phase, where there's sort of, it's obvious at every point in time that you want to scale up, there's enough money for it. You have some slowdown due to the infrastructure taking longer as it gets larger. It's sort of unclear how long that lasts. I think that to some extent, 2030 might even be aggressive for how long this lasts, and what it looks like at the end, sort of unclear. But our modal case we're talking about, this continues till 2030. It's making a substantial but not very dramatic impact on GDP. And then there's the second stage, where you start seeing this explosive economic growth potentially, and this feeds back into investment. And even though it's slow, even though the amount of investment is limited to 1 generation ahead, at this point you might not even be able to invest 10x more than that because you might not have 10x more than that. My overall thought on this is that I think it's very reasonable, and there are numerous very good arguments, that if you get to the point where AI can automate all of the jobs, you have explosive growth. Seems totally right. If AI could do...
Let's be precise. Like, what's explosive economic growth in this context?
At a minimum, 30% GDP growth per year. Although our models often give much higher. I think if you automate all the jobs, absolutely you're getting 30% economic growth per year for many years, for at least 5 consecutive years. You get on average 30% economic growth.
Yeah.
And quite possibly much faster. If you can automate all of the tasks, you'll get this explosive economic growth. And right now we can only automate a fairly small percent of tasks. I think in terms of economically useful tasks, it's very hard to put a number on this, but probably more than 0.1% and less than 10%.
Yeah. I think right now my kind of a rule of thumb that you can have here is like, if you want to get to the point where you are increasing growth rates by an extra % in a year, in that year, you need to automate like 1% of the tasks that people are doing. Like that seems to me like a rule of thumb, which is like approximately correct. And that I do believe that by the end of the decade, we're going to be living through a fast enough period of growth that this is going to be true.
I'm not sure if I have more uncertainty about this rule of thumb than I think you do. It doesn't seem unreasonable to me. But the thing I have uncertainty about is, right now we're at some small number of tasks, very small % of tasks that are being automated, maybe less than 0.1, I don't know. And if you get to 100, you get explosive growth, very fast. at some point in between, you're going to start seeing less than explosive, but still fairly substantial effects.
Yeah.
I have a lot of uncertainty on where that is. You seem to think that, you get like substantial growth effects at a few percent being automated a year. This doesn't seem unreasonable to me. I've also, could be persuaded that the number is much higher, that the amount you need before this is much higher, especially if you want to maintain growth. But fundamentally,
Yeah, to be clear, if you want to maintain growth,
you have to keep automating it.
You have to keep automating.
Yeah, and if there's even a slight speed up in this, then you will see, not super long after it, you'll see all of them. The question is, at what...
Well, I'm actually, this part I would like, long after that, you will see all of them automated, not long after that. I will actually
Or not
contest
super
that
long
too.
after, a decade or something.
Yeah. Oh, okay. In a decade, that's enough time. But here, like the subtlety that I want to point to is automating cognitive tasks. I feel is gonna be way easier than automating a task that require physical input. And this is a big hurdle that we're gonna have to face somewhere in the next decade.
Yeah. Okay. What's my thought on this? I think I'm definitely much more skeptical of this claim than you are. I'm definitely pretty skeptical. A lot of tasks, there's a few things going on with automating physical tasks, and maybe you can point to which ones are the ones you think are going to be particularly difficult. There's just the difficulty of making robots that can do tasks. There's the cost of producing those robots, and then there's the actual intelligence necessary to do those tasks.
Yeah, I think the former are the ones that are gonna be the bottleneck. Like the later ones, I don't think so much. The cognitive part is yep, you're gonna have the software. In principle, if you had the right data for it, you're gonna be able to automate it. But still, in order to match the productive capacity of billions of humans, you're gonna need billions of operators out there, and those take some time to manufacture.
Yeah. It's not clear to me how much time those will take to manufacture when you're at the point where this will make you $1 trillion. It's also not clear to me how obvious it will be and how close the cycle time will be on this. But right now, it certainly seems to be the case that you can get humanoid robots that are worse than humans for an amount of money where the interest on them would substantially exceed the amount of money, the minimum wage. So it definitely doesn't seem, even if you had the software problem solved right now, doesn't seem like you would see these robots become much cheaper. There's a few reasons these robots be implemented on a massive scale. There's a few things that I think are important to point out here. One is that even if you aren't at the point where you are actually replacing people with robots, you could be at the point where you are replacing skilled labor with unskilled labor, where people are holding up their phones and it's telling them, highlighting exactly what they should do, or maybe they're wearing a headset to tell them, although that feels less concrete. Yeah, maybe
Mark Zuckerberg was right.
Yeah, maybe Mark Zuckerberg was right. We'll see augmented reality. You could also just imagine people holding up their phones and it uses their camera and then does an animation showing them exactly what to do, where it monitors their hand movements with a body cam and will tell them if they're doing something wrong. There's a lot of things you can imagine that are just of varying degrees of complexity to turn potentially highly skilled blue collar work or pink collar work into unskilled labor in this way. Where even if you don't have the robot bodies, you'll have a lot more people who can work on things. It's unclear how much this unlocks, but it seems very possible to me that this unlocks a much, much larger workforce. There's also a bunch of, if you have AI monitoring people, things like quality control are a lot easier. You have AI seeing everything at once. If you've solved all of these software problems, humans make decent robots in a lot of ways. They might not enjoy it, and the amount of wages you'll have to pay them will vary. And this will have a lot of, I assume for a lot of people this sounds like a very unpleasant way to live. On the other hand, there's a lot of people who don't have access to jobs, much less jobs that pay pretty well. And so there are probably going to be a decent number of people, a large portion of people who are willing to take these sorts of jobs. And the amount of education, access to resources they'll need in order to outsource these things will go down by a lot. And this will allow, I think, for a lot more manufacturing output in a lot of places. Just being able to utilize human workforces at much higher level. This will also drive some combination of outsourcing and also falling wages, unless something's done to prevent this policy-wise. This also happens for white-collar jobs even earlier, and the sort of knowledge worker jobs. We're just like, you still need a human to do it. You need a human to check over it, but you don't need the human doesn't need. There's not actually a reason for to hire the human who's good at it. You could just hire the human who's, says they'll do it, but then really uses AI, and the quality of work is the same. And you can't really distinguish. You ask your friends what their experience with this person was like, and they're like, yeah, it was good, because that person, and under the fact that the person's, not actually skilled at their job doesn't really matter, and this means you'll see falling wages, because anyone will be able to do it, and they'll just undercut each other. Unclear how long this will take. But the lack of skills, the de-skilling of jobs, probably happens in a lot of areas before you see full automation of jobs, especially in blue-collar jobs, I expect. And this will have a large amount of economic effects. It's unclear to me how much you unlock by de-skilling blue-collar jobs.
To me, this doesn't seem as big of a deal as eventually you have AI, that's the thing, and you are able to scale that up to a very large degree.
One thing that's unclear to me in particular is how much cheaper and easier to scale up does manufacturing get? Let's say you can build your robots. How much cheaper and easier does this become if you suddenly have, several billion people who are suddenly capable of doing high-skilled technical jobs because of AI oversight? It might be that this substantially increases the ability to produce something like robots, and that you just see a substantial increase in manufacturing output from this. That will then potentially lead to, robots because you hit limits as to the number of people. But it's very unclear to me how far you can get on de-skilling human labor alone. And it seems very possible to me that you can get to the point where robots become much cheaper and more numerous.
Yeah, and I think my stance on this is that I don't believe this makes that large of an effect. I do think that it makes enough an effect that is substantial. Potentially, I could see you growing 50% your production of robots through reallocating human labor. I don't think you get much more than that because of two things. The first one is, it's just hard to reallocate all of that labor to work. It's hard to coordinate. The second one is you're still going to be bottlenecked by the capital. You only have that many machines. And even if you have a surplus of operators that suddenly are skilled, you still only have the same machines. You have to build more machines. Eventually, this is the kind of thing where the economy kicks into place and you get to build all of the machines and you continue growing. Yeah. I don't think this is going to be the primary effect that dominates.
It's not clear to me how long it takes. If you've solved the software problems, and everyone understands you've solved the software problems, you've demonstrated this. Yeah. And it's just a matter of selling cheaper machines. It's not clear to me. Also, of course, at this point, possibly the main effect here is actually going to be from automated R&D, according to me. I'm not sure if you agree with this. Just human AIs that are able to optimize and design cheaper versions of these machines seem to have potentially a very substantial impact at this point.
I don't think I believe that. I think that the primary effect is still going to be driven by you build a new version of the machine, you see operators use it, and then you go we realize these things that you can do to make it better, and you iterate on that, and this takes a bit.
At this point, you don't have to iterate it on one. You can have 100. Possibly this will look like startups or something. Yeah. You could have a lot of people try a lot of ideas at once. Yeah. There's not very many limiters on that.
Yeah, fair enough.
And this seems very plausible to me that makes a huge difference. Just the number of, the scale at which you can iterate might be might be very substantial. The scale at which you can try new things.
Let's maybe get back to the bigger picture of what we're trying to figure out here. At which point do you expect we're going to have AI that basically can automate all cognitive tasks as cheaply and do them as cheaply as a human?
When I'm asked this question, I typically say 2035.
Yeah.
I do want to note my 90% confidence interval on this is going to look something like 2027 to 2050 or 2045.
Reasonable.
It's going to be, I think that I don't want people to mistake this for, oh, this is definitely, I take a much faster and even some slower timelines pretty seriously. But when I'm asked for this, I say 2035.
Yeah, I did a little bit of thinking on this, not much, and I arrived at a model point of 2034.
Yep, okay, so we're pretty much in agreement here.
Like the way that I arrived at 2034, so it's very crude, but I'm thinking about like, okay, if by the end of the year we're training models so like 1,000 times more compute, then like this is gonna be like a gap equivalent, this is gonna be as large compared to GPT-4 as the gap between GPT-4 and GPT-2. And like I kind of think about like, okay, what do I expect that model to get? And it's like, I expect that model to be really impressive. Like again, I do think that solving open problems in physics and mathematics, I do actually believe in the model that automating all code that's been written by humans, just the code writing part, that seems correct. I do also expect that there's going to be this long tail of cognitive tasks that are like pretty hard to automate, where like humans have been like particularly well optimized for that, for things like fine motor control, things like keeping track of the strategic situation, or like keeping coherence and identiness, which to me seem like they might require a little bit more, and then like a little bit more is like, well, it's that another 10,000x gap in compute. It's like, no, I don't think there's like 10,000 gap in compute. Maybe it's like half of that. And then like, given that we expect infrastructure build out to slow down, it's like, okay, maybe we will already have models trained on like 100 times more compute than by the end of the decade, by 2034.
Yeah, I think I'm like less certain than you about the specific tasks. Fine motor control, definitely.
Yeah,
I buy.
yeah.
The other cognitive ones I'm maybe more skeptical of, but just from the fact that I don't expect AI to be able to do cognitive tasks in the modal world, don't expect this to happen until 2035, which is, I think I did a similar amount of effort to get this number as you did.
Yeah. Like I wouldn't want people to over update on the specific things that you said. Like for me, the more important thing is there's going to be some cognitive tasks. I wouldn't be able to say which ones a priori.
Which take a little bit longer than the others. Yeah,
that's right.
I absolutely,
That seems about right. So let's talk about like, what does this buy you? Even if you have, in this model world, again, where like things just scale up, everything goes kind of like according to plan. If you get to automate like if you get to AI that can do all cognitive tasks by 2034, 2035, like what does that get you in terms of impact in the world and what AI can do? And then like for me, like I think this has a large impact. Like I think this can already get you to the point where you get 10% growth, 10% growth a year. In a way that can be sustained over a few years. Like that doesn't seem insane to me. I think if you want to go farther than that, I actually start to believe that you're gonna need the robots, and the robots might take a little bit longer to get built.
Yeah, I think I'm less confident than you are on this. In particular, it's like there are a lot of things that cognitive labor might unlock. Making robots much cheaper. It's very unclear to me how much this can be done by just running a large number of experiments in parallel. Like if if experiments give a few bits of information each time, you could just run 1 million experiments at a time. And this is the same as doing iterations like 7 times faster or whatever, or 6 times faster, however fast you want to go. And if AI is making, hundreds of billions of dollars, the thing I just described might only cost you, tens of billions, maybe 100 billion. It's like a huge investment, but it's not 3x your current revenue. And if you're like pretty convinced it work, it seems like a profitable thing to do.
But it's still hard. Like even if you are only automated cognitive tasks, if you don't yet have the robots, then like right now, like we did some estimates of this, of like how many tasks right now are like remote only, so to speak. And we got like, 30% of tasks that people do today in the US, like 30% of their time is being spent collectively on remote only tasks that could be automated with just brains without robots, which it's a bit. but it's not that much. It's something that can get you like 30% growth that you automate progressively over over say a decade. Like maybe that can get you up to 10% growth a year. But I don't think that can get you to like 30% growth a year.
So we don't really look like a world where doubling the number of the top 1% of researchers gives you very, very dramatic gains, to the extent where it might be possible to do that. Like we put resources into training better researchers, but we're not willing to give up 10% of our economy to train to double the number of to double the top 1%, which I might expect it to be if it were that effective.
So I think that key thing we should be discussing here is like whether we should expect by default for AI to be different in kind and have different scaling properties here. Like if we expect that for humans, like even if you put twice as much labor into R&D, like you get only these very modest returns, which I do totally believe.
Yeah.
Like why will AI be different?
Yeah, I mean, so a lot of the questions here are plausibly you're putting a lot more than 2x. You're plausibly putting 100x or 1000x just because of inference. Like a lot more. The R&D, like we currently have this where, once AI can automate a task, it gets automated, especially cognitive tasks, the amount of it increases dramatically. And, even if this is, not something you can necessarily keep increasing each year, a one-time 1000x in the amount of researchers, this seems to me like it very plausibly, and maybe if depending on how you follow the numbers, you might actually get very, very dramatic impacts from this. Even if you look at explosive economic growth, this could still easily give you, many years added to human lifespans. This could give you wild technologies that just aren't the explosive economic growth type. This could give you, I know Dario Amadei talks about basically every cancer getting solved, basically every disease getting solved, doubling of human lifespan, and things like this, which are, you don't necessarily, even without the insane economic growth, you might start seeing things like that, which are just a very, very large deal. Also, even without this explosive economic growth, the amount of economic growth will still seem really fast and intense to everyone.
Yeah.
Like even at 10%, it's just, that's a lot.
Like I definitely do not have here a rigorous argument against it. Perhaps an intuition that we can give is there seems to be a limit to like how smart of a choice you can make when you're designing an experiment. Like eventually, when you have like a million scientists like working really hard on coming up with like, okay, this is like the optimal next design that we're going to try, then like that this bottoms out, right? Like you eventually have like this idea that then like other people can look at and be like, oh yeah, this seems like a good idea. Like I don't expect to be these super brilliant ideas that are hard to understand.
So there's a few models here. Mm-hmm. One is that that marginal scientists you can't really increase the number of experiments you're doing a lot. Marginal scientists improve the quality of the experiments.
Yeah.
Another model is that deciding on what experiment to do maybe not actually that hard. And I think this is true for, to some extent, these are extreme models. But you can see AI increasing just the sheer number of experiments you're trying.
Yeah.
I think this is the world I imagine. Not where 1 million people try on one experiment, but where there are 1 million AIs doing 1 million experiments, and where you're able to deploy capital at a much larger scale.
Yeah.
Arguments against this are of the form, like right now, then why aren't we training more scientists right now if this were going to be so effective? And this is, a very valid point, but plausibly there's, much more investment costs in terms of investing in the people running the experiments. Even all of the labor involved in experiments is hard. Like lab experiments, you'll need people who are trained lab technicians and things, and if you're de-skilling these jobs, that's also a very huge deal. And it seems very plausible that just automating cognitive labor drops the cost, it allows you to substantially increase the number of experiments you are doing. Depend more in software than some other things, but there's a lot of other places where it seems plausible they'll let you do it without that. Also in a world where you're getting much wealthier and you've suddenly de-skilled a lot of labor, there's just a lot more people who are unlocked as potential workers. I would be pretty surprised if this doesn't speed up technology substantially. Whether this is enough to give you an explosive economic growth on its own is less clear to me. And you could see, 1,000x in cognitive labor on scientific tasks very quickly, and this could very well look like an increase in scientific progress and just a general R&D that looks like skipping ahead a decade or 2 decades.
Wait. Say that again. What gets you to skip a decade or 2 decades
If you can
ahead?
add 1,000x the number of researchers you currently have. If you can 1,000x the cognitive
in a
labor.
year, you get a 1 decade increase. That seems wild to me.
Do I want to walk back this claim? Maybe my actual take is this. This will vary a lot by field.
Yeah.
There will be some fields where it's slower and faster. The fields where this has a huge impact will have an outside impact on the world. It will be the most noticed ones and will be the most impactful ones. And there'll be some where it's less than a decade, and maybe the median or whatever, the average is less than a decade, it's 3 years, whatever. But there will be enough there might be enough instances where it looks more like a decade. I think that I'm not sure actually, this is much more gut-based than numbers-based to some extent. I think we both basically agree on a substantial jump ahead. Like 3 years on medical science it's pretty large, especially because I think you keep seeing this increase in speed because as the AIs get to do more experiments, and also maybe you see this 3 years and 6 months. It just the amount of from the perspective of someone watching this happen, it will feel truly wild, I think.
I don't think it will feel truly wild. The way I like thinking about this is in terms of economic growth.
Yeah.
And in terms of if you have a world that's moving like 3x faster,
yeah.
both on the scientific side but also on the economic side, this is like a growth rate that you should expect like 6 to 10% a year, which to me is like that seems that you could get that with AI. That seems that's something you could totally get.
Yeah.
I think my model world in 2034, like we get to this like 10% growth a year, which is
I mean, if you're
wild.
moving 3 times faster, it's been since 1995. It's been 30 years, so that's in the next 10 years you would get the same level of technological change that you got from 1995 to now. Yeah,
you get the smartphone. You get these new fancy vaccines that we have. Yep. You get like all of this AI
you get, like,
progress.
Significant advancements on treatment for HIV.
Yeah.
That like substantially change how it impacts the world.
Yeah. In a decade.
I mean, maybe we'll get used to it and we'll think, oh, this is just the speed technology increases at. But at first, like, this will look like things are moving very fast.
Yeah. And I don't want to overly litigate like this speed.
Yeah.
Because here, the point I'm making is about the speed that you get at the beginning and without like any robot automation.
Yeah, we think without robot automation, you get a amount of speed which looks like a lot. It's not the extremely wild outcomes that we'll talk in a bit on a lot of technology. Also, I'm not sure how much you keep this up for a lot of technologies. I think like you probably get a boost and it slows down a bit as the impact of additional thought. At this point, it's unclear. Maybe you do keep it up for a while. I mean, large amount of uncertainty around all of this. Yeah. Also, I think just in terms of impacts on the world, I expect the impact on the labor market and on people's jobs and livelihoods to have secondary effects, even at this point.
Explain
that? I expect high unemployment and incredibly high de-skilling, a lot of jobs that you might make a lot of money from. You either don't make money from or the jobs don't exist. When we had a substantial spike in unemployment during COVID, we saw a several $1 trillion stimulus package being passed in a bipartisan effort by both parties. Almost overnight. By a bipartisan effort, almost overnight. This is the ability of the United States government and the people in general, and the American people to respond to labor changes and to these sort of situations is impressive and honestly quite rapid. And the incentive to do so and the desire to do so is, I think, very much there.
Yep.
I think that you will see very large societal reactions to AI.
Absolutely.
This is before 2030. where this becomes, a dominating issue for elections. I think I expect all parts of AI to get a lot more attention just because they're all associated, whether it be existential risk or just ability to actually automation in particular, or the infrastructure costs or the effects on the environment. I expect all of this to get a lot more attention and a lot of policy to happen, and for this to affect everything a lot. And just like in terms of what do I expect, if I think in 2030, I'm thinking about what are the big news AI things. I'm going to be like, yeah, the big news AI thing is that now everyone is talking about this AI a lot, and they're talking about, to some extent, the significant technological strides they've made, and also how there have been a significant increase in, you probably see a significant crime spike just from unemployment. It just happens. There's been a lot of turmoil, a lot of chaos, a lot of major, probably the government people attempting really dramatic things to deal with this. And this to be one of the most salient things about the world. And one of the most,
Seems about right.
Yeah. Definitely by 2035, probably by 2030 in our modal case, I think you start seeing this. It's one thing that's unclear is how fast do you get the unemployment effects.
Yeah.
This has to do with to what extent are different tasks correlated on a given job.
Yeah.
And if they turn out to be pretty correlated, meaning that jobs go from no AI to fully automated very fast, because any given task is going to go from no AI to automated very fast, I think, then it seems pretty likely that you see a lot of jobs. If they're very correlated, it seems pretty likely you'll see a lot of jobs that are automated very fast. Even if they're not, you'll still see a lot of jobs that are automated pretty fast, just slightly slower. And this just is the secondary effects of this sort of thing is going to be extremely substantial and maybe one of the...
It's a big deal.
Yeah.
It's going to be a big social thing.
Yeah, it's going to be very hard for a lot of people, and hopefully something, if the economy is doing well and technology is doing well, hopefully there's things that can be done to actually make this a good world for people and make sure people benefit, both in the short term and the long term.
Yep.
I'm optimistic that this will be possible, though it seems very likely it's going to be a painful time for a lot of people regardless of this.
Yeah, got ya. Okay, let's go back to a summary of where we are with our timeline and where we are standing. We have described again this world in which AI keeps being scaled up over the next 4 or 5 years. We reach a lot of automation. There's a lot of unemployment because of that, and that this already has measurable economic effects. AI keeps moving. Infrastructure keeps being scaled up at a slower rate after that, so that in our model world by 2035, we have AI that's really, really competent, that can basically automate all cognitive tasks that a human can do. And this is already enough to get you to 10% per year growth, which is a 5x increase over the rate of growth that we're seeing today in the US, a 3 to 5x increase. This is already a really big deal. And I feel if you want to go beyond that, for me, the robot question starts becoming super salient. When do you start building robots in this timeline? For me, it's a really important question.
I think what is maybe more important to me is the degree to which returns to intelligence continue. I think this is a bigger question to me is, maybe all these things, all these best guesses we have apply to humans right now, but do they apply if humans can get way smarter?
Yeah.
I really don't know. And maybe in fact, I think it's very reasonable for someone to say that, sure, maybe the top 1% of humans isn't a huge deal now, but imagine the top 0.0000001% of humans. You can imagine that you effectively push someone a standard deviation smarter, they have maybe a substantial more impact. And you're not limited on how many such people you can get because they're AI. I think this is my uncertainty in question more so than the speed at which you can get robots.
What do you think about this? what happens if you replace the human population with von Neumann? If you von Neumann the world? I'm like, I think this has an effect. I do think that this is, you get like a speed up from that, and this compounds with like the effect of like, oh, suddenly you have access to like much more labor.
Yep.
I do still think that this is the kind of thing that, this still seems the kind of thing in my model world, which is very uncertain, is the kind of thing that helps you move maybe twice as fast and not something that helps you move like 100 times as fast.
I think I agree with you on this. The extent to which this feeds back into itself and lets you scale up faster is a big question for me here. Our current thoughts on algorithmic progress, and on this is the main question of what happens here.
In my model world, like algorithmic progress is super tightly correlated with compute.
Yes, I think we both agree on this. I have a lot of uncertainty, and it's a very important uncertainty. But yeah, in my modal world we're discussing here, algorithmic progress is a result of being able to run a lot of experiments.
And specifically experiments at large scale.
At sufficiently large scale, possibly growing scale, and possibly quite a lot of experiments, and running them fast, you can iterate. There's a lot of support for this, I think, just if you read explanations from the top people in ML as to how they do what they do, or as to why something works. It definitely seems very plausible that this is the case, and that even making a bunch more like AI researchers who are smart doesn't actually have a huge impact compared to being able to run experiments. At which point, this means that when your growth in compute has slowed down to, a tenth of its current speed, then you will be at a point where, algorithmic progress will also slow down to a tenth of its current speed. So you see this sort of magnification of the impact of compute, and importantly, you overall see a lot slower. If this isn't true, I will know algorithmic progress takes over as the most important thing, by far, because the compute scaling slowed down. This has a lot of implications for like who in the world do you expect to have a lot of compute or power. It just comes down to this bunch of researchers. Being able to invest a lot of money isn't as important. But I think we both agree that modal world seems really likely, that it's the vast majority experiment related to having a lot more, yeah.
Well, even in this world,
yes.
Algorithmic progress is still very tightly correlated with like inference compute.
Yeah, right now it definitely like, if you ask people how they do, if you talk to people about, why don't they do some research about something, it's often that they're compute bottlenecked. Yeah. It's a common complaint by academic research.
And I'm getting at the point of like, if most of your algorithmic progress, even in this world where like algorithmic progress is not tightly correlated with like the scale of the experiments, like you still need like this large workforce of AI scientists to do the algorithmic progress for you.
Sorry, because
AI scientists take compute to run, and if you have like 1,000 times more compute than other factions, then like you're gonna be able to translate that into a lot more algorithmic progress.
I do think that in this world, in the world at which you don't actually need experimental compute, maybe, or either it doesn't go that fast or you don't need much.
Yep.
I think once you can automate AI scientists, you get wild superintelligence basically the day afterward. Yeah. You get like, this is the world where AI 2027's ending looks basically correct. Even if yes, it's the case that compute is still important, the like thing you have very soon after, within a year of that, you have a world which looks wildly sci-fi compared to the present, and I don't want to predict anything at that point.
So what I identify is that the three key things that we will want to understand in our model world to see how fast things are going to be moving after around or after 2035, we need to understand better like how quickly are we manufacturing robots, what are the returns to scale to further scientific labor, and what are the returns to intelligence and to getting AI that's substantially smarter than humans.
Yep, I think those are the three. I think that if we're talking about modal world, we're not like accounting for politics and response. Like this is what happens. It's useful to understand what happens if you don't do interventions. People are going to do interventions, but useful to have a baseline so people can understand sort of what they're intervening in favor or against. And yeah, I think that this is absolutely, I think those are the main three things I would focus on as important questions to answer.
Yeah. If I had to venture a guess of what's 2035 beyond,
Yeah.
I'm kind of more on the side of skepticism to seeing like these very fast returns to scale in science and returns to intelligence, where like I will freely admit that a lot of this is rooted on, it's hard to make guesses on it, but I think I will still say that. And then like the robot question for me, there's a question of foresight of like how quickly are investors convinced that this is going to be like the next big thing and start investing in that early enough to already have the robots when we can get to automate all of these, when AI will be good enough to use them.
I think my take here is that it seems very plausible that by the time this is a major question, the revenue from AI will be so substantial that some AI company will not even need to spend a very large amount of their money on making this. If they think it's plausible, it'll just be like a small budgetary item compared to what they're not building them in bulk will be. But also even like, if it's $100 billion investment, let's say to be efficient, you need $100,000 per robot body. Seems pretty likely. So, what does this mean? If it's $100 billion, you get 1 million robots. It's not as many robots as you'd like. It's a fair point. If it's $10,000, $1 trillion.
Robots are expensive. Like
even if they're $100,000, right now the various improvements might, but right now, I think my impression is $100,000 to $1 million for a humanoid robot that's not as good as a human.
Yep.
You do need to get that down, and it is when we're talking about AI, it's very easy to get used to things 10xing or 3xing. We're improving at this very fast pace. This is how we're used to thinking about it. I've said that before, that if something's not improving at least 35%, the speed of Moore's law per year, then why do I care about it? It's not moving. Most things don't move at this speed. AI is unusual, and expecting that like something that might cost $1 million now will be less than $100,000 in many years is a big difference. It requires AI R&D being done by AI to have had maybe a more substantial effect than we expect. So yeah, I think that this is this does seem to be reasonable that you need to lower the cost more than I expect to make it better than human labor to do these things.
And that's a big deal. I think this can substantially slow you down. Like one intuition pump here is when you look at how many cars we make a year, like worldwide we make like 100,000 cars a year. And obviously the robots at this point are like much more useful than a car. You're going to have like a much stronger incentive to make them. But at the point, to me, it makes a big difference. Like, when do you realize that this is going to be the case and start preparing for it? If like if you just want to go from now to producing 100,000 robots a year, then this might be equivalent to producing a car.
Sound like a great case, a great comparison here, just because the amount of cars you make is limited by the number of people who want them. And once you get to the point the features and everything, it is the case that going from not making much of something to making 100 to making even 100,000 or tens of millions, pretty hard. If I were to spend, let's say you're taking it seriously, your AI is a huge deal, you spend $10 trillion on $100,000 each robots. Then you're getting to the point where that's 100 million robots.
Like
that's a big deal.
$10 trillion in a year, even in 2035, with AI being like this big of a deal, is still a big investment.
I mean, the thing that this really looks like is, you spend $100 billion and then you spend $1 trillion as fast as you can.
Yeah.
But yeah, you spend $10 billion and $100 billion. Spending $10 trillion at the point we're currently discussing, still a big deal. But it might not, you test it out with $100 billion first.
Yep.
Not that much.
Yep.
You start making a bunch of money. It's also sort of unclear how many robots you need to automate to lower the cost of doing all of this.
Yep.
Um,
Well, I think you need it. Like one intuition here is like if you want the robots to have this measurable effect on how fast things are going, is you need to have at least as much robot labor as human labor.
I'm specifically saying about the speed at which robots are being built.
Yeah.
You get at least as much robot labor involved in the construction.
Yeah.
Which it's sort of unclear to me how many humans and how much human labor it's not obvious that you need more than 1 million or more than 100,000.
100,000 humans working. Can you say the statement fully?
That at a point of 100,000 robots, you might be able to make robots substantially faster by having the robots make themselves. If this is the case, then you spend $100 billion on this, you see it works. It's very easy for you then to, spend $1 trillion on this, and then 10 trillion, and now you're at the point where it's 100 million robots. It's a big deal.
This still has taken you like 3 years to get there or something.
This still has taken 3 years.
Yeah.
I definitely think like 3 years from the point at which you first see 10,000 robots, totally reasonable. There's a lot of like details here. The robots are not currently as good as humans at things.
Yeah.
Even if you're willing to spend more than 100,000. And so it's like, there's a lot of things that have to go right here. But 3 years after the robots, you're at a point where like maybe traditional economics no longer is a good way of modeling this.
Correct. So in our model timeline, to put this all together, 2035, you get full automation of cognitive labor and people start building the robots. And then it takes like 3 years for this operation to fully pan out. And then like by 2038, like you have this army of robot workers on that number in potentially in the hundreds of millions to billions. Is that kind of the world we're imagining?
This is by 2038. And then I would like to note, by 2040, we are at the point where my forecasting fails. It goes bananas. Things are wildly sci-fi. I don't know what's happening, but don't assume that just because it takes 3 years to get to a third of the labor, there's 100 million or a large number of robots. The next stage after this might look very intense.
That seems correct. That seems correct. What good comes after the world comes bananas? How quickly you go from 2038, you have all of these billions of robots to you build a Dyson sphere and capture all the energy output of the sun. My claim is that
5 years.
No, I don't think
less.
I think that more actually. I think this is very hard to think about in my model world. It's probably more than that. Where one way that I think about this is so roughly right now, if you wanted to get at if you wanted to capture the energy output of the sun, that would be 14 orders of magnitude greater than where we are than the energy output of the Earth right now.
Okay.
And if you wanted to get there, if we were naively growing energy output as we're doing now, at roughly 2-3% per year, it will take you 1,000 years to get there. And it's can you go 10 times faster? Absolutely. We have already credibly established that you can go 10 times faster than that. Can you go 100 times faster than that? Can you can you get your growth rates to get 100 times faster than that? It's I don't know. I think in my model world, you hit something along the way. It becomes, there's something there that slows you down.
Yeah, I don't know. Any roadblocks you might hit on the way sound like the sort of thing that could be solved. I think my actual take here, this goes back to something we were talking about a bit earlier, where the question is how much is superintelligence get you? Because the prior, you've actually not able to scale that fast arguments fail again at this point, and suddenly you're able to scale compute very fast.
Yeah.
Once you have robots you have this scale up right now that slowly slows down as infrastructure becomes a problem, and then you eventually solve enough problems that you unlock these robots and infrastructure stops being a problem, or at least the speed at which you can scale suddenly starts becoming this more intense exponential again. That isn't as linked to the prior economic growth. and I am like, the next you spend 4 years training in scaling up, you spend 4 years doing AI iteration, and then it does something with nanomachines. I don't know. I'm just like, man, you can get a lot of progress, just in terms of like, maybe this is wrong. I think your argument is like a reasonable baseline as well, but also, yeah, I don't know. At this point, we'll have gone from AI contributing 0% to AI contributing 1 to AI contributing 10 to AI contributing 100% to GDP, basically, something like this. And each of these stages is only taking a few years. It doesn't seem unreasonable to say that there's AI contributing 1,000%. It's just like at this point, the curve. If you draw all these points out, it looks it doesn't look exponential. It looks faster than that.
Yeah. Here, I think that what will point to my intuition is this idea of we have gone over like 10 doublings or so of the economy in human history. And at some point in the last century, like growth rates, in fact, stopped accelerating in like frontier economies. Like we hit a roadblock, which like economists debate exactly what it was, but it is undeniable that in fact growth rates stabilized for like at least a period. I think that you could get like a gap like that, and that makes it so that it takes you at least like 2,000 years.
I don't know.
To
you
get
see,
there.
like in the first, my vague impression of something like this is 10,000 years ago, human economies start growing, and eventually you get like this industrial revolution. They grow even faster after thousands of years.
Yep.
And after a few hundred years of that slows down briefly. But just a brief patch of this is slowing down. And this, if you want to draw this sort of line, which I don't know how much you can, but if you want to draw this sort of line, it looks like the 20th century is a little bit of a speed bump, or not even, but a little bit. You maybe see a little bit.
I don't understand what you mean by.
I'm
speed
saying
bump.
that like it hasn't actually been that long of a slowdown since AI takes over, and suddenly we go back to speeding up.
Right.
And the gaps between these, like, the gaps between the increases in speed seem to be shrinking a little bit.
Mm-hmm.
And so, like, it seems totally reasonable to be like, okay, any further slowdowns will also, like, it just, the overall arc of human history in this argument looks very much like super exponential, with, like, a little bit of noise in somewhat recent history, but.
I think eventually you get there. Growth rates keep growing until you hit some physical limits.
Although
and then it's like kind of unclear where those physical limits lie. I do think that you hit some bottlenecks around there. Like there might be like energy. It might be like available space to build in some kind of ways.
What's our gigawatts of energy use for AI in 2040? What's our modal case?
I'm not gonna give a number to that. I'm not gonna give a number to that. This is.
I did this. I got I don't know, yottawatts maybe. Who knows? Petawatts.
Yafah watts. Okay. Yafah, I want to move towards summarizing what we have said here. Like over this conversation, we have tried to develop what I will call the default epoch model. Like maybe not call it the epoch model. I'm not sure the rest of our colleagues will necessarily agree with it. But it's our best guess of like what happens to AI if current trends just continue as they have so far.
Yeah, which we think a lot of these trends like by default continue unless something interferes.
That's
right.
That's right. And to me, it does seem like we have identified like these 3 periods of AI development. Like there is from here until the end of the decade or so, where like you roughly can continue the current pace of like crazy scaling that's being enabled by redirecting investment from the world into this new technology, continuing the rapid build out of AI infrastructure that allows you to train bigger models, deploy them at large scale, and automate like more and more tasks over time. And to me, I think that this is already enough to get you to a world in which like AI is something like very economically impactful. on the order of like already adding like a couple of percent points of growth per year to the US. A world in which like we break out the spell of like stagnating growth rates due to this new technology, which is insane to me.
Yeah. No, it's like, it's, even at this point, like, I think it will be very obvious to everyone, even at this point, that AI is the most important invention that's happened in their lifetimes. At some point, it will stop seeming like all of our conversations are about AI, because there will be so much AI that it will just be specific subsets. It will become this very huge part of everyone's lives in this world. It's hard,
It's hard to overstate. It does seem that then by the end of the decade, like it's still like not every cognitive ability it has been automated. There's still like a long tail of some cognitive abilities that resist automation by AI, but maybe they're not that far away. And even though we also get to the point where like it becomes much harder to scale, not enough to completely slow down scaling, it just becomes so ubiquitously useful that people want to keep scaling. But every extra order of magnitude, like it requires like more and more time for planning, for infrastructure build out, more investment that needs to be justified, and that overall slows things down but doesn't stop them completely. And then like roughly, like, you know, our model story is by 2035, like every cognitive task that humans do, essentially AI can do just as cheaply. Maybe they do not do everything, because we do not have like enough robots to automate all physical tasks, but they become like these force majeure economic, which like speeds up economic growth significantly. Like here I'm envisioning a world in which AI is earning trillions of, companies are generating trillions of dollars of revenue, where like growth rates worldwide are getting to 10% growth or greater. And that doesn't seem to me that insane. I think that this is something that could perfectly happen in this model world.
Yeah, I think it's pretty reasonable to expect this at this point, which is wild and feels too much. But, you know, it does seem pretty reasonable. I do think it's also, I think this is our modal world. I think there's a lot of like very reasonable considerations which point to things going much faster. But yeah, no.
That's right. And then I think that to determine exactly like how fast things are moving here, and how fast they're going to be developing over the next years, like we identify like these three factors where like we need to have a better understanding. Like we need to understand like how quickly you can build robots and deploy them to do useful work. We need to understand like what are the returns to a scale, especially when it comes down to developing new technologies, and what are the returns to intelligence as you keep building AI that becomes like progressively more sophisticated and like outsmarts humans, not only by a small margin, but by a wide margin.
Yeah, to a large extent, depending on if the first two, I think with these three factors, we would basically have put our modal worldview together. We have like guesses for them, but I think on all three of these, we are pretty uncertain and like don't really feel entirely comfortable with our estimates for, especially compared to a lot of our other things.
Yep.
And they explain a very wide variety of possibilities.
That's right. And then like regardless of that, then like we still have like this confidence of eventually you build the robots and eventually you get to the point where AI has taken over the economy essentially. And that puts you into this new economic regime of hyperbolic growth where like it's just very hard to make guesses about how fast that goes, how long you can keep that regime going for, and like what is the final scale of the economy that you can get once like 10 years after that fact, for example.
I think depending on some of the answers to some of the hard questions, it might happen before robots are even relevant. But we definitely think that given all of these things, that you eventually can get to this point.
But yeah, like how I will summarize
in our modal world. In our modal
world, of course.
Like there's also possibilities that you see a more sharp drop off in scale might push out timelines pretty far, or you might have things that happen faster earlier.
Yeah, how I would like summarize like this whole model viewpoint that we've been exposing here is these three eras from now till the end of this decade, the next 5 years, like this scaling era where like you keep things moving fast and you see this rapid growth, and like you see this commoditization era in which AI becomes like this force majeure economica that gets us to at least 10% growth a year by 2035, and like potentially we get to automate every conceivable cognitive task. And then like from 2035 to 2040, 2045 or something, at some point there, like you get this transition into this new economic regime where like AI is the economy, it's driving everything. We shift into this fully hyperbolic growth, and then like our models break down. Like I want to be very transparent about it. Like our models break down in this world.
Yeah, I forecast out to the point at which things become bananas, is the term I use in my head at least.
Yeah.
That like, in this modal world that we're discussing, that happens around then.
That's right. And I mean, I think this is, to me, something that, I don't know, to a degree is like something hard to believe, because when I stop to think about the consequences of it, it's very crazy. But when I try to go through where is the fault here, I'm not sure if I can find it. Everything that we have said of how the world develops, like it does seem like it could happen. I think this exact story, obviously, it's very, very unlikely.
I think there's a lot of different choices here that like where we're unsure and we need to make a decision when like we feel like we can pick a modal outcome or we can guess, but it could go either way. And it's not one thing in particular that I think about in regards to this is that it's not clear to me whether if you just made some of these choices differently, a lot of the times this will lead to a much faster world, and a lot of times this will lead to a much slower world, which I think is a good thing. I think that this world that we just discussed is one where I both strongly feel that it's too fast, and I strongly feel that it's too slow.
An interesting epistemic position.
Yeah, no, it's just which I think is a good sign, to be clear. It's just, if I think about it one way, I think about, wow, this sure has a lot of research being done without it having this giant effect on anything. Yep. That's sort of bizarre. Scientists are running it several times faster, and there's a lot more of them. It feels, off, and that, it feels like it should go a lot slower than that. Mm-hmm. Feels like, maybe you hit the end of scaling and it just stops. Or like scaling continues, but at similar speed, and like.
Or people are reluctant to scale. Maybe they go like, well, we're not seeing that many economic returns out of this. Maybe we'll want to go 10x bigger. Yeah,
this is also a possibility. Like, there's a lot of, and then there's a lot of things, that like. Sorry, which one were we doing? Things that made it go slower or faster? I thought we were just doing things that.
We're doing things that could make the trajectory go off. Model.
It can go a lot slower, especially given just like the world we're describing is one in which it's radically different from ours in terms of the amount of growth and the events, and it's sort of on some level feels like even from the current trends, we haven't seen those current trends lead to an entire world that's changed this way. And I am sympathetic to people who are like, oh, you're just drawing a straight line through a few points and extrapolating it out wildly far. On the other hand, I think we have enough data to say that it looks sort of like all of these straight lines exist, all these trends are real. And in terms of the impact of these trends, it's very substantial if you work them out. We are creating intelligence, and there's a good reason to believe this is different than a lot of other technologies of the past. And so far, current events seem to hold up with this interpretation. It's like, I think that this world makes me happy in terms of neither feeling way too fast or way too slow to me.
Yeah. Maybe one thing that I will add is this distinction between models and medians. I think that this is my model. I think this is what the exercise of me just randomly saying like, okay, what is the next most likely thing to happen? I do think that my median is slower than that, actually. If I were gonna put my median, I think I will put it like substantially farther than this, like potentially a decade later than this. I could see more ways in which like this gets slowed down than ways that it gets speed up. I do see a very compelling way that gets a speed up that we have discussed through returns to intelligence. But I do think that my AI timelines are such that my model is like substantially ahead of the median.
I'm not sure if my modal is quite as far ahead of the median, although I do think if you start going a bit slower than this, you do end up, having some more dramatic slowdowns. The faster worlds are a lot more salient to me.
Yeah.
And also when making decisions, feel a lot more important.
Yeah.
And I don't think this is unreasonable. If I think there's like a decent chance of those faster worlds in terms of things I can have an impact on now, and to things that, we can think about, worlds at which AI is worlds at which you get this hyperbolic growth in 2030 or sooner, are just some of the most impactful things to work on and consider. I'm hopeful that we'll get more focus on thinking through those outcomes as AI scales. I don't expect those outcomes, and that I think they're definitely less than 50%. But I think I spend a decent amount of time thinking about the faster worlds than and I think that this is in fact on some level correct.
Yep.
Those faster worlds are in fact more important to think about, but it's also useful to have a baseline to be able to look at in 2 years. It's useful to be able to look and say, okay, did AI go a lot faster than we expect? Just in terms of, the next 2 years after that, is it looking like the modal world? Is it looking like AI did in fact go much faster? It's useful. A thing that's very useful of having this sort of world to think about is in 2 years, AI is going to look wildly more advanced and important and doing wildly, there's in any world, in very many worlds, including our modal ones and fast ones and many slower ones, and I'm sure your median, AI looks way bigger and more impressive and doing way more sophisticated things in 2 years. It's useful then to be able to say, okay, but is this on trend for even faster than we expected, or the slower, or the same? Because even in slow worlds, AI looks like this. And it's useful to have, set out some sort of standard to judge this against, so you can avoid. There's going to be a temptation to update towards the faster worlds, just based off it being very cool.
Yeah.
And in some respects, there will absolutely be some results that look faster than others and are surprising. Some things that are really surprisingly advanced. And it's useful to have these metrics and this discussion of what's the benchmark? What what can we measure against to check if this is actually?
Yeah, one thing I'm very much looking forward to is now we have this concrete thing on record that economists are going to point to and say, like, these people are insane. They say we can get to 10% growth a year by 2035.
Oh, well, look, yeah.
And then, like, the AI people, they're going to look at us and they're going to be like, oh, these people are insane. That they only projecting 10% growth by 2035.
Yeah, I'll be pretty happy if, I agree. I agree. I think that there will be some people who, man, who am I more sympathetic to here? I'm definitely more sympathetic to the economist side of this, even if I think it's more important to think about. I think my actual take here is, I'm much more sympathetic to it's insane from the perspective of it's insane that it goes this fast.
Yeah.
But I think it's more important to do work and more salient to me, the potential for it to be even faster.
All right. Any closing statement, Yafah? Something you want people to remember or to take away? The single thing you want people to remember?
That the default world trends continue, nothing very exciting happens, is completely wild.
I'm into that. I think that to me, this is a world which feels quite plausible, and this is still a world in which all AI can replace all cognitive tasks by 2035, and it can replace all human labor pretty much by 2040. This is very insane.
Yeah.